In this explanatory visualization, we visualize an aggregate drum dryer for hot mix asphalt production. The dataset range from 750 to 1,125 time steps, with each time step consisting of approximately 1.4 million points and cells. We leverage the ParaView connector to import the Aztec dataset into Omniverse. The Omniverse ParaView connector is simple to use. You'll need to first configure the connector by specifying the Omniverse Nucleus server you want to connect to, and also the directory to store the generated USD files. Once the connector configuration is complete, just launch the Omniverse connector render view, and now everything you load in ParaView gets synced with Omniverse. In Omniverse, you can use the Create extensions, represented by the solid black line, to modify and render the USD scene. Create provides very high quality materials specified using the open source material definition language. Create also allows you to light a scene using high dynamic range image illumination. Here's a sampling of what Omniverse has to offer. Create has a default selection of assets that you can place in your scene. Custom assets can be imported from a digital content creation tool like Blender or Maya. Here's how it all comes together using ParaView via the Omniverse ParaView connector and leveraging the various extensions in Create. The Aztec double-barrel drum mixer is a counterflow dryer and continuous mixer designed to perform efficient drying followed by thorough mixing. The rotating drum is constructed of a large rolled metal plate forming a long cylinder. 4 metal flights attached to the internal surface of the drum to prepare aggregates to be mixed with other ingredients. Entering the drum where the dry aggregate exits to enter the insulated mixing chamber, we see the first 2 sets of combustion zone flights. They are then followed by the veiling flights. And lastly, we see our conditioning flights right before the gravity chute. Aggregate enters the drum through a gravity chute. The conditioning flights at the inlet end break up any clumps or sticky material. Showering or veiling flights lift and pour the material evenly through the drum where hot gas streams transfer heat to the cooler, moist aggregates. Here we see the combustion zone flights. Combustion zone flights spread the material to maximize radiant heat transfer as well as to protect the drum shell from damage that can occur from the high temperatures generated by the burner flame. That's not shown, but would be connected to the same region as the combustion zone flights.